Okay, so after graphing on the homework, I hope you realize graphing is not the best method. What's the reason that you would think graphing isn't the best method? Well, I think it's because what if they cross at a fraction? How do you tell the difference between 1/2 and 1/3, or 7/8 and 9/10 on a graph? Other reasons would be if the numbers are really, really big or really small, making a graph that intersects at 57, 22 would be a lot, right? And so that's why we have some algebraic methods. And there's two methods that maybe you remember. One of them is substitution. And substitution is exactly what it is. It's exactly what it is when you do it in geometry, or any time that you say like x equals 7, so what does x plus 3 equal? When you take that and replace x with 7, that's substitution, right? So the substitution method says you solve one equation for one of the variables and you substitute it into the other equation, so then you can solve for one variable, okay? So let's just jump in here. If I was going to solve this question by substitution, step one is I got to solve for either x or y. It's your choice, but usually you want to solve for something that's easy to solve for, which means like something that has nothing in front of it. So I think it's going to be really easy to solve for x. So think about if I did that, could I subtract 2y over here and get that x equals 8 minus 2y? That's the same thing, right? Substitution says if x equals this, can I take this and substitute it in for x over here? And why do I want to do that? Because I can't solve an equation that has both x and y in it. But look what happens now. If I rewrite this equation, replace x with what x equals, which is 8 minus 2y, minus y equals 18. I now have an equation that has all y's in it. So that's what substitution allows us to do, to substitute in. So now I have an equation with y in it. And now I have to know how to solve an equation. So I'm going to distribute. Half of 8 is 4. Half of negative 2 would be negative y minus y equals 18. These y's are on the same side, so I'm just going to take negative 1 and make negative 2y. And I'm just solving for y here, kids. So to undo this positive 4, I'm going to subtract 4. Notice how I'm keeping track of my work so I don't lose negative signs. So I get negative 2y equals 14. Divide by negative 2, and I get that y equals negative 7. Is that my answer? No, because my answer is a point, right? So this is just solving for y. I also need to know what x is. And you could take this y and you could go back over here. You could go back here. But I think it makes sense to go back right here. Because if I already know that x equals 8 minus 2y, can I just substitute in negative 7 for y to get x equals 8 plus 14, or x equals what, 22? So this is my answer, and you can circle it like this. You could also write it as the ordered pair of 22 comma negative 7. Either one of those is correct. If you really want to check your answer, you can plug it in and see if it works to do that. So let's check really quick. If I plug 22 in for x, that would be 2 times negative 7. So 22 minus 14, does that equal 8? Yeah. Or if you plug it in the bottom one, half of 22 minus negative 7 equals 18. So 11 plus 7 equals 18. So that answer makes both of these true. So you can check if you want. I don't need to see the check, but you can check if you want. Okay. What about this one? Which letter would you solve for? And again, you have options, okay? Honestly, on this one, you could solve for a because we could just divide by 2 here. On this one, I could solve for a by dividing by a negative 1 at the end. So I'm going to solve for the bottom one. If you solve differently, we should still get the same answer. So if I'm going to solve for a in the bottom, I'm going to subtract 2b over. So I get negative a equals negative 3 minus 2b. But I need to get the a by itself. So I'm just going to divide everything by a negative to make that positive 3 plus 2b. Now, if that's what a equals, I'm going to take that and plug it back into the other equation for which variable I solved for. So I get 2 times 3 plus 2b minus 4b equals 6. So when I work that out, I get 6 plus 4b minus 4b equals 6. And again, these are on the same side, so this just cancels out, and I get 6 equals 6. Which is a problem because I don't have a b to solve for. And so this is where our special cases come into play. Either this is no solution or this is all solutions. And it's all about whether this is true or not. Does 6 equal 6? Yes, always, which means that the answer here is infinitely many solutions. Or if I graphed these equations, they would end up being the same equation on the same equation. So just a reminder, if it's no solution, if it's parallel, you're going to end up with something that's not true, like 6 equals 0. That's never true, so that would be no solution. But if it's the same line, you'll get a true statement like 6 equals 6 or 0 equals 0. So that's how you can tell if it's a special case without graphing it. What else do we want to do? We want to talk about story problems with systems of equations. So remember that a system of equations should be 2 equations and 2 variables. So you want to kind of think about what the 2 variables are. So in this question it says, at Amy's amusement park, tickets sell for $24.50 for adults and $16.50 for children. On Sunday, the amusement park made $6,405 from selling 330 tickets. How many of each kind of ticket was sold? So that last sentence kind of tells us what our variables are. Each kind of ticket, right? So I'm going to say A equals the number of adult tickets. And I'm going to see C equals the number of children tickets sold. And you should have 2 equations here because we have 2 variables. So what do we know? We know the prices per ticket, right? So if it's $24.50 for adults, can I say $24.50 for adults plus how much for students, or children, sorry, $16.50 for children. And what should that equal? Should that equal the money I made, or should that equal the number of tickets I sold? This is money, so it should equal money, $6,405. The other equation comes from this. It better equal the total number of tickets. So my other equation is going to equal 330, but I have to figure out what am I going to put over here. Well, the money doesn't matter for the number of tickets, right? So that's just going to be the number of adult tickets plus the number of children tickets, which means that this could set up very nicely to be substitution, that I could solve for either one of these. I could just say A equals 330 minus C. I can take this and I can plug it in up here and use my calculator. And I'm going to stop. I'm not going to finish this because I wanted to do this in class with you, but you can try it or we'll start here in class on this problem. Okay, but I want to get to the other type of question before I take up too much time. The other way to solve this is elimination. And maybe you remember elimination is when you eliminate one of the variables. Elimination I enjoy much more than substitution. And so these are some steps for you. You might need to multiply to make the letters the same or opposite. And then you can add or subtract the equations to solve that. So substitution would also work on this, but here's what I love about this problem. If I want to eliminate the x's, could I just subtract this top equation from this bottom equation? And so I'm going to subtract, and so I'm going to go through and I'm going to subtract everything. And look what happens. X minus x is 0, which is what we want. We want to eliminate one of the variables. 2y minus 1y is y, and 10 minus 6 is 4, which means right away I know that y equals 4. But just like in substitution, you still got to go back and find what x is, and you can plug it into the top equation or the bottom equation. I'm going to plug it into the bottom equation and get x plus 4 equals 6, so that means x equals 2. So my answer is 2, 4. Elimination isn't always that simple, because what if they don't eliminate? Like on this one, if you eliminate if you add or subtract these, nothing's going to eliminate. So that's where you might have to multiply by something to get it to eliminate. Multiply one or both equations by a number to get them to eliminate. So you have to decide if you want your x's the same or your y's the same to eliminate. It doesn't matter. It just matters if you do it right. So if I make my y's the same, what's the first number that 3 and 2 have in common? 6. So what would I multiply this by to make it a 6? I would multiply by 2. And on the bottom, what would I do to make this turn into 6 or negative 6? I would multiply by 3. And as long as we do it to everything, we haven't changed it. So look at the top. I get 4x plus 6y equals 24, just multiplying everything by 2. And if I multiply everything by 3 here, I get 15x minus 6y equals 33. And then look what I did. These already cancel each other out, right? 6y minus 6y is 0. So I'm going to add these equations in order to get 6 plus negative 6 to eliminate the y's. And I'm left with 19x equals 57. Then I can divide by 19. And I believe that x equals 3. This saves a lot of fraction issues in substitution. The hard part is you got to go back and you got to plug 3 in either to this equation, this equation, this equation, or this equation. So if I just plug it into the top one, that would be 2 times 3 plus 3y equals 12, or 6 plus 3y equals 12. Subtract the 6 over, and I get that y equals 2. So I get 3, 2 as my answer. Okay? So I know my video is going kind of long. I got one more story problem that we're going to work on, and we'll finish up the other one. But if you could try to figure out your variables on this, try to set it up, that's where we'll start in class. And then there's a nice thing that kind of talks about what's the best time to use each of these, and we'll talk about that in class